All right, wonderful to have you here today. So welcome to this community call, the last one in May, number 83. My name is Mark Fussell, and I'm your host today. And we have a tremendous lineup of speakers today. We have Jake, who's here to talk about Kratix and Dapr integration, a great project we've been working together to join these two communities. And then we have Alessandro, who will dive into the crypto APIs, an alpha set of APIs that we've introduced in the upcoming 1.11 release, and also talk about streaming perf improvements we've done into service invocation. And then we'll finish up with Mark giving a little recap of some of the news and the events that have been happening inside the Dapr community over the last couple of weeks. There's been some pretty exciting things that the community have posted. And then we have maybe a little bit of time for some open discussion. I just want to before we dive into Jake's section, I just want to point out that there is a RC available for you. The 1.11 RC is in progress. We're trying to ship it. It'll hopefully come out next week is our intention. But right now there's an RC6 available for you along with the CLI. Please download it. Please try us out. Please give us feedback. Please go on to Discord and tell us anything that you found. It's incredibly important that we get some feedback from the RCs, you, the community, trying out your scenarios and trying out the features that are important to you on the RCs gives us lots and lots more confidence. So we really thank you greatly if you can take this and give us any feedback. There's also some RCs for some of the SDKs as well, for example, like the .NET one here. So try that out, give us a feedback, post it on Discord. So with that, I'm going to switch over and let Jake take control and talk about Kratix and Dapr. Jake.
Awesome. Thanks, Mark. Let me just share my screen. Can you all see the slides?
Yes.
Awesome. Cool. So I'm here today to talk about Kratix and Dapr. So first of all, I guess a brief introduction. So my name's Jake. I'm an engineer at a company called Syntasso. And we're working on an open source product called Kratix. So I don't know if many of you saw Mauricio's blog that he released last month. It was all about building your platforms with Kratix and Dapr. It's a great blog. I recommend you read it. I'll put a link in the chat once I'm done. But what I'm going to do today is just talk through again about how Kratix and Dapr fit together and also give a demo of using the two combined. Cool. So I guess getting started, I'm relatively new to the Dapr space. Only in the last few months have I started to hear about Dapr, started using Dapr, mainly thanks to Mauricio showing it to me. And one of the parts that I was most impressed about Dapr was all about the Dapr components. I've worked on projects in the past where I've had to interact with things like Redis and Postgres, etc. And I've the idea of having this single interface to interact with all these different components, all these different services, made a world of sense to me, and I could really see the value in having it. But one thing, chatting to Mauricio, we talked about is how Dapr and this high-level interface makes it really easy for your application to consume these services, but it doesn't necessarily solve the problem of getting the services provisioned in the first place and Dapr configured to use them. So that's sort of where Kratix comes into it. So what you might have today if you're an application team using Dapr is that before you can even start developing your application with Dapr, you probably need to have an environment set up, right? So you might spin up a Kubernetes cluster and install Dapr, but that's probably not enough. Once you've got Dapr installed, you probably need to also configure a state store if your application needs it. So you're going to have to install Redis onto your cluster. There's about 100 different ways of being able to install Redis onto a cluster. If any of you are familiar with Kubernetes, there's a million different ways of doing the same thing. Maybe using a Helm chart, maybe using an operator. But you're going to have to, as an application developer, you're going to have to go figure out how to get your Redis and then wire it up to Dapr. And the same can be said, if you need a pub sub, you might need a RabbitMQ. And if you need a secret store, you might need a Vault. And it might be that you're interacting with services that aren't even running in Kubernetes. Maybe you have a dev Vault instance running in the cloud. And once this is all wired up, it's all great. You can take the full value of Dapr, and it's amazing. But there's quite a big initial cost there, right? You have to do all the work to get your environment and to get all of your services up and running. And one thing I'm guessing that happens in a lot of organizations that are big Dapr users is that this happens a lot across all the different application teams, right? If all of your applications that you're developing are using Dapr, they're all going to have to go the effort of getting a Dapr environment with all the services and having them configured and wired up. And what you probably find is that the different teams are using different backing components. One team might use Redis just because they're familiar with it and they know how to deploy it. Another team might use Cassandra for no other reason that they're comfortable with it. But there's a lot of duplication that's happening across all these teams, right? Every application team is having to go and do all the hard work to get their environment set up. Once it's all set up, it's great, it's amazing, but there's that initial cost up front, and there's also that cost of maintaining it, right? You might have people within your organization telling you that you need to make sure you're running secure versions of Redis or that you're keeping it patched, etc. So there's quite a big cost associated with it. So some of you might be familiar with the term of like platform engineering. It's like been quite a buzzword for the last few years. And this is the whole idea. The whole idea is that with all these application teams, they're all going to have a duplication of effort. And what you should really have is one team that tries to reduce all the effort by taking responsibility for it. So if we go back to the previous example, it might be that you have something as simple as a platform team that's there to manage your Kubernetes clusters for you, right? So rather than every team having to manage the Kubernetes clusters and all the Dapr installation and all the components, that sort of one aspect gets taken away from it. So it's one less thing the application developers have to think about. But why stop there? You could go further. You could take away the Dapr installation as well, have the platform engineering team manage that. You could keep going and reduce back the amount of complexity that each application team has. But that's not very easy to do, and that's sort of why I'm here today. So Kratix is a framework to building platforms. It's trying to make it easy to do exactly what I just described. Because the reason a lot of companies are doing it today is because it sounds really easy, but the reality is it's actually quite hard. So what do you have to do if you want to go and take all these different components and have one central platform team that's responsible for providing it to your application teams? Sorry, I've got a bit of a cough. So Kratix is trying to make this easier. So Kratix has the concept of promises. So promises are a way of providing services to your application teams on demand through an API. So Kratix is built on Kubernetes. And because it's the platform team that are offering these services, the services that they're offering can be customized to your org. So if we go back to the slide, we can see that, like I said, originally it could just be that they take Kubernetes and that you have maybe a promise for offering Kubernetes. Could go a step further, so you could have a promise for offering Dapr or for offering the various different components like state stores. And that's all somewhat reasonable, right? You can imagine that just being able to offer Redis on-demand self-service to application teams has reduced the complexity that they all have as individual teams. It's one less thing they have to worry about getting set up before they can start using the Dapr environments. But as you can see on here, there's more than just like one or two pieces of duplication. All of the teams are essentially doing the same thing. They're all setting up a bunch of components in Dapr. And the fact that they're actually using different components, like Cassandra or Redis or AWS Secrets Manager or Vault, doesn't really matter if you're, because of how amazing Dapr is and the fact that it doesn't matter what the backing component is, what the infrastructure backing the component is. The application teams probably don't really care. They probably have only diverged just because individuals within that team actually have the expertise to install and manage those software. So while you could offer something like this, like just Rabbit, Redis, Vault as a service to your teams to make their lives easier, you could really go one step further. And instead you could offer like an entire environment as a service, right? So an application team could come along and say, I just need an environment. This environment needs Dapr and a few components. I, as an application team, I don't really have many opinions about what version of Dapr or what version of Redis, or if it's even Redis, using Redis at all. I just need like access to an environment that has Dapr and all the components. And yeah, you can imagine how much easier the application team's lives will be if that was in place. So what I'm going to do now is show a quick demo of using Kratix to actually deliver that sort of experience. So I'm just going to switch over to sharing the terminal. Can you see that?
Yes.
Awesome. Thank you. So what I have locally is I have a Kubernetes cluster running. So I'm using Klein. It's just a tool for running a local Kubernetes cluster in Docker. And all I have installed is Kratix. So if we take a look, we can see that the Kratix pod is running. There's no other pods running apart from Kratix. So as I mentioned, in this demo, I want to show off delivering Dapr environments as a service. So putting my sort of platform engineer hat on, as a platform, I want to offer Dapr and all the related services to my application teams as a service. So to do that, all I have to do is teach the platform about my promise that I've written that provides that. So what I'm going to do is I'm going to create the promise. And what that's going to do is that's going to install the promise on the platform. So if we take a look at what promises we have, we can see that we have an environment promise, and we also have a couple of other smaller sub-promises that have been installed. So like I mentioned earlier, when you're writing a promise, you can be as low or high level as you want. So you could be offering Redis as a promise, or you could be offering Dapr or a whole environment with Kubernetes. And the great thing about Kratix is that it's very composable. So what we've done here is I've created an environment promise that actually under the hood is just going to do calls to other promises. In this case, when you request an environment, it's going to request an instance of Dapr and also request an instance of Redis. So this is all about this composability of like making it easy to pull in different components. So we've installed Kratix. We've installed the promise on the platform. So now it's ready to receive requests from the application teams. So if I was to put my application team hat on now I need to go about making a request to the platform. The standard way you might do this is you probably have some internal documentation within your organization that your platform team will publish, or maybe you're using something like Backstage, which provides a nice UI for like discovering what services are available. For this example, I'm just going to show like a local manifest. So if we take a look at an example request, this is what a request that the application team would make to the platform would look like. So we can see what we're doing here is we're making a request to the platform. We're saying, I want an environment. I want it to be called my dev environment. And we're also providing some specification about what that environment should contain. So like I mentioned earlier, the platform teams define what the API is, and they can define as high or low level abstraction as they want. So in this case, they've said you can define, do you want a state store? And what should the state store be called? So in this case, we're saying, yep, I do want a state store, and I want a state store just to be called state store. And for an example of making this demo a bit quicker, I've also said, should I also deploy my application at the same time? And I've said yes. But you could imagine a world in which each organization has a different relationship with the application teams, and it might be that you want a higher or low level abstraction. It could be that the specification is just like a list of components, just like, yes, give me a pub sub, yes, give me a database, or it could be absolutely as high or low level as you'd like. So I, as an application developer, I've written my request, and now I can make it to the platform. So I'm going to go ahead and send that request across. So what that's going to do is that's going to fire up a request pipeline. So Kratix has this idea of request pipelines. So every time somebody makes a request for a promise, a pipeline will fire, and that pipeline will be responsible for bringing about the changes in Kubernetes that are required to fulfill the promise. So in this case, the pipeline's going to fire. It's going to set up Dapr. So by set up Dapr, I mean configure the components for Dapr. It's going to make a Redis request to install Redis. And it's going to deploy the user's applications as well. And this is all going to happen behind the scenes. So if, like, from the application team's point of view, I've made my request. I don't have to do anything more. And if I was to get my request, I can see that it's been requested, and the platform is going about doing that. So if we were to take a look at what pods we have, we can see a few different things are happening. So my applications are being deployed, and my request pipeline that I ran earlier finished. Like I mentioned earlier, because we have one promise making request to other promises, what's happening now is that the Redis request is coming through. So my environment has made it like another request to get a Redis. And what we're going to see is eventually a Redis instance will appear, which we can see now, and that started to run. And what's slowly going to happen is after Kubernetes goes back and forth, it's going to have the Redis instance running, my application's running, and wired up to Dapr. So just while these pods come up, if I take a look and see what components I have, we can see that the state store component's been created, and it's been named how I wanted it to be named earlier. If we were to take a look at this, we can see that it's been wired up to use the Redis instance that was running locally. Because it's just a demo, I've set no password, just trying to show it off. But we can see, if we take a look at the pods again now, that the Redis instance is running, and eventually, once Kubernetes is happy, these pods will restart and get up and running and be using Dapr. So yeah, that's like the main run through here. Hopefully it won't take too long. There we go. Pods have restarted and now they're running. And if we were to take a look at some of the logs for the pods, we should see that it is using the state store. So like if we were to take a look at the logs in the Java app, we should see that it's loaded the state store component and it's talking to it. So yeah, that's just a quick example of using Kratix to provide Dapr developer environments on demand. And yeah, I'm happy to answer any questions if anybody has any.
That's pretty cool, Jake. Actually, one question I've got is, where do you specify where your applications are going to start as part of your environment? Where do you put those?
Yeah, so in this example, just for the sake of having like a quick example, I've just added one field here that says deploy the applications. So what this means is that the platform team has already encoded in the promise, like, oh, what application should I deploy when somebody says that? I've done that just for the sake of the example, but you can imagine that rather than deploy applications, this could have a list of, Docker images that should be deployed, or it could be completely left out entirely, and it could be up to the application team to deploy the applications. This is where the you can change the sort of make the interface like higher or lower level depending on what your the context of your organization is.
It's pretty cool. So, I mean, let's open it up for questions. And does anyone want to ask any questions of Jake? And
yeah, hey, this is Yaron. I don't have a question, just a comment. Actually, this looks pretty cool, and I'm definitely gonna take a look at it because it looks like it can save a lot of time just getting an environment up and running.
Cool. Yeah, thanks. If you want to read more about it, you can go to kratix.io, or you can just Google Kratix. We have a great set of docs for getting started and using it. And Mauricio's blog as well on the Dapr website goes into great detail about using it. So yeah, both great resources to check out.
Okay, thank you.
Cool.
Yeah, I'm just looking in the chat window here. No, there's any other questions, but yeah, post those links in the chat window, so people can follow up on that. And once I see someone's posted a blog post as well, so that's pretty awesome to go and read that, and then people go and find out more. But it's amazing to see that there's a rise of these platform teams and using them in order to set up these environments. As you say, it's pretty tricky, and with the combination of Dapr and its component model in the environments, it's a great blend of having those two together that just puts a platform together for you pretty quickly.
Mark, I think we have Tom with his hand up.
Oh, Tom, do you have a question?
Yeah, that's okay. Yes, Jake, on Kratix, is it just in CLI for now, or will there be a UI coming out?
That's a great question. So because Kratix is just built on top of Kubernetes, like everything about how the API interact with Kratix is all Kubernetes. Any API that works with Kubernetes will work with Kratix. So that could be Backstage, it could be any interface that works with Kratix. So at the moment we haven't got our own one, but we have a great blog about using Backstage, and any Kubernetes dashboard would work.
Okay, got it. So yeah, so we could use a third-party open source UI for now. Okay.
Yeah.
But then other than that, it's just CLI then, right?
Yeah.
Okay. And you can use kube control or kind, I think you were using as well.
Yeah, so I was just using kind to create like a local cluster, but you could run this, in EKS, AKS, GKE, any Kubernetes provider will work with open source.
Or sorry, kubectl. I don't know how it. Or kubectl.
Kubectl, yeah.
Kubectl. Everybody pronounces it differently. Sorry. Yeah. Thank you.
Kubectl for sure.
Is it kubectl? Okay.
I decided it is, so
All right, really cool stuff. Excellent. Thank you, Jake. So with that, we're going to move on. And Alessandro, you're up next. So why don't you share your screen and take it away and talk about the crypto API?
Perfect. So yeah, thank you. Good morning. Can you all share my screen? Is it working?
Yes.
Perfect. So I'm actually going to present two things this morning. And the first one is about the new crypto as in cryptography APIs that are landed in Dapr 1.11. Okay, so first of all, why are we doing this? Why are we building this? So the main benefit that we want to bring is that we want to allow developers to build apps that use cryptography for better security. There's many things that you can do with cryptography, but the main one is that we want to allow you to encrypt and decrypt data. And this is what we can help with by making it much simpler to use cryptography and to do that in a safe way. Crypto isn't a silver bullet that will immediately make your apps completely secure, but it's an important feature that will help you make your app safer And it can also help with complying with certain policies and requirements like data privacy regulations around the world. For now, in Dapr 1.11, our primary focus is on data encryption. We want to allow you to encrypt and decrypt arbitrary data, so you can store that in databases, share it with other Daprized apps in your solutions, etc. The data being encrypted means that even if someone were to hack into your database, for example, I don't know if someone remembers the situations where S3 buckets were left unprotected, they would not be able to do anything with the data. So it makes sure that even if you were to get hacked, attackers will not be able to do anything with the data. And so just like Dapr provides an abstraction to various state stores or to various PubSub components, we designed a crypto building block to provide an abstraction layer on top of key vaults, including cloud services that you see here, such as Azure Key Vault and equivalent ones from Amazon, Google, etc. You can also support services like HashiCorp Vault, which is something that can be self-hosted. In 1.11, we currently support Azure Key Vault only, but the other components, we welcome community contributions, for example. The beautiful thing is that when you use these vaults, they all have APIs that they can perform crypto operations within the vault. So your keys never leave the vaults. For example, you can send a message to Azure Key Vault or HashiCorp Vault and attach some data to the message and tell Key Vault, please encrypt it for me. And Azure Key Vault will send you the encrypted message back using the key stored inside the vault. This is a very important security feature because these vaults store the keys very safely. Sometimes they even use things like hardware security modules. And your keys never leave the vault. So it's less risk that your keys be compromised because you know that they're always kept in a safe space and they never leave there. To add to that, also these vaults allow you to have audit logs. So you know who uses the keys, when, and for what. And so this gives you a lot more visibility into critical security components. And what Dapr offers on top of that is an abstraction. So you know that the crypto building block will work with all of these vaults. Right now only one, but all of these vaults. And you don't have to worry about different implementations, just like in every other Dapr building block. If you don't have a vault, that's still not a problem, because in Dapr 1.11, we also included what we call a built-in crypto engine. In which case the crypto operations are performed within the Dapr sidecar. So Dapr does have your keys, but all crypto operations are in the sidecar. So your app at least doesn't need to handle the keys. It's not as good as having a vault service, but it still allows some separation of concerns and it still keeps your keys protected in a different way. And the built-in crypto engine works with keys that are stored in local files, Kubernetes secrets, or from a remote endpoint through JSON web key set. All of the above is just so really to make sure that your app doesn't need to handle keys. And when you let Dapr do that, then you know your keys are safe and protected and less likely to leak. So the crypto building block is actually a 2-for-1 kind of building block. In Dapr 1.11, we're only releasing the high-level APIs, which allow you to encrypt and decrypt data using the Dapr encryption scheme version 1. This is an opinionated scheme that just works. So we use modern and safe cryptography, and it's designed to work efficiently with data as a stream to be fast and still secure. It's a new encryption scheme, but it's based on prior art, including things like Google's Tink, Filippo Valsorda's Age, and Minio's Dare, which are all based on the same research paper that are about performing stream-based encryption safely. We have designed this scheme together with the experts of the crypto board at Microsoft, which approved the design and believe it meets the requirements for enterprise usage too. And so did I mention also that it's safe? Most users will want to use the high-level APIs that we offer in Dapr, which make things simpler for developers that might not necessarily be versed in cryptography. We'll see a demo how it works in just a second, but the idea is that Dapr takes care of the complex stuff and potentially dangerous stuff as well. You just tell us where your key is and which data you want to encrypt and decrypt, and we do everything else for you. In the future, we will also have some low-level APIs, which we call subtle, because they're pretty much just an abstraction layer on top of the various key vaults and the Dapr built-in engine. So these are called subtle because they're called subtle like right after what JavaScript does. If you look at the MDN docs, there's a thing called web crypto, and in there are the subtle APIs that you use in web browsers as well. And we call them subtle because they're very low level, and you must handle them with great care. With these low-level APIs, you can perform all crypto operations, including encrypting and decrypting, wrapping and unwrapping keys, and generating and verifying digital signatures. And although there are some guardrails in Dapr, these APIs, they give you the flexibility and power to choose how to use them. This also means, for example, that if you want to encrypt data with AES, you can choose the mode of operation, like CBC or GCM, and you must handle nonces and authentication tags yourself. Some of you might already see the pitfalls in here if you have some experience working with this stuff. If this stuff is used incorrectly, for example, while we don't allow insecure mode of operation, so we don't allow ECB mode, for example, you're still also responsible for things like nonces and for making sure that nonces are never used if you use GCM mode. So like I said, the low-level APIs, they give you a lot of power, a lot of flexibility, but you must handle them with care. The low-level APIs are implemented, but they're not yet public. You can technically enable them if you really want to by recompiling Dapr and using a Go flag that I'll show you later. We haven't enabled them because we are still unsure how to best expose them, and we actually would really appreciate your feedback on this to make sure that when we expose them, we do this the right way to address your actual needs. The reason the SR APIs right now are still implemented anyways, even though they're not exposed, is because the high-level APIs are built on top of that. So for us, it was pretty much like a low-hanging fruit. And we do think that there are situations where they can be useful. For example, if you need to use other schemes for compatibility with external systems, like if you need to interact with GPG, or if you want to use operations that we do not have a high-level API for, like using digital signatures or using algorithms like elliptic curves. So let's move into the first demo, which is using the high-level APIs to encrypt and decrypt things. So here I have one app, which is using the Go SDK for Dapr. And in here, we are going to encrypt a file and then decrypt a file. So this is all that you need to do to perform encryption using the Dapr SDK. You need to have a client to the Dapr SDK, just like every other Dapr API, and then you need to call encrypt. You pass a stream. In the case of Go, this could be a file or could be something that you create with like strings new reader. This way you get a string. You get a string from a string, a string from a string, and then you just pass the encryption options. We just need to know the component name, your key name, and if the key is of type RSA or IS. You can also specify, in case you use IS, which key wrapping algorithm to use, but usually it's enough to just type RSA or IS, and this is all you need to know. This is all you need to encrypt and decrypt files. Decrypt, it works the same way, and it is here. And again, you just call client.decrypt, you pass the stream, and then you pass the key name. This is optional if the key name is the same that was used to encrypt the file. And then you get a stream and you can write that to file. So in this example, I'm going to do encrypt and decrypt first, this image. And then I'm also going to encrypt a very large file to show the performance. In this specific case, we are using, so right now we are encrypting the image. There it is. And now we're about to encrypt a 10 gigabyte file. So the image has been encrypted, and you can see it here under ENC. If I try to open this, you see that there's a bunch of gibberish. But at the beginning, there's this thing, which is the magic number, indicates that this is a file that was encrypted with Dapr, with some data that Dapr needs to decrypt the message. For example, the kind of the key that was used and the wrapped key, and then a signature that makes sure that this can only be decrypted with the right key. And this was the file that was original, and this is the file that was decrypted, and you can see it's exactly the same. I'm going to go back here, and you can see that it's still working on the large file. So the encrypting small files, of course, is a little bit less efficient because you have to first wrap the key. The key is also wrapped with Azure Keyboard, so there's a network call. But you can see that we encrypted a file of 5 megabytes in about 2 seconds. This is from my machine. So it's not too bad considering the latency of going to Azure for encrypting this. And then we go into something that is really fun. Here I've encrypted a large file, which is 10 gigabytes. And this one, as you can see, was encrypted 10 gigabytes in 24 seconds. So a speed of 421 megabytes per second. And this is really as much as you can push the performance. And I think at this point, the bottleneck is really just the NVMe disk on this machine. If the disk were faster, the Dapr would probably be faster as well. This code that you can see here uses components that are defined here as resources. In this case, there's nothing secret in here, so don't worry. In this case, you can see that I'm using Azure Key Vault and I reference the component of type crypto.azure.keyword, just like every other Dapr component. I reference which vault my key is, and then the credential to authenticate. It's missing the client secret, so you're not going to be able to do anything with this stuff on screen, so it's okay. But alternatively, you can also pass keys using the built-in crypto engine. In this case, I'm using a JSON web key set, and we have a component that supports that. It's called crypto.dapr.jwks. All the crypto components that have Dapr in the name means that they use the built-in engine. In this case, I'm passing the key set explicitly as a value to the component. I could also pass a file, or I could pass a URL here. And we'll see that how it works in a moment. So, okay, so this was the demo of encrypting and decrypting files. We saw how we can encrypt using the Go SDK. In the next week or so, we will also have a TypeScript SDK, and SDK for other languages are going to arrive in the future. So as a quick recap by the high-level APIs, you can see the white paper that they use. So the schema that we use is standardized in this white paper. It's public and it's in our Dapr Kit repo. And these APIs are available for both gRPC and HTTP, but you should really always use the gRPC one via, using the Dapr SDKs. This is because the gRPC APIs use two-way streaming, so they're actually extremely efficient. The Dapr is encrypted or decrypting the data as soon as it gets it and sends it back to you. So they don't use memory, significant amounts of memory in Dapr, and your data comes back as soon as possible. We do have HTTP endpoints for completeness, but we only intend them to be used for testing because they do not allow for two-way streaming. And so they have much worse performance and also much higher memory consumption. This means that if you want to encrypt a 10 gigabyte file using HTTP, you have to first send 10 gigabytes to Dapr. Dapr will keep 10 gigabytes in memory, and then will send you back the response. While if you use gRPC, you send the SDK chunks the data, sends Dapr, I think it's 2 kilobytes of data. Dapr encrypts it, send it back right away. And this is all happening instantly, so there's no need to cache all the data in memory. So a lot more efficient. I also want to show you a demo of the low level, the subtle APIs, which is something that I mentioned is not available in Dapr 1.11. But I just want to show how these work. And again, looking for your feedback on how we can best expose them as well. So I'm just going to start Dapr without any sidecar. And for these ones, I'm going to use HTTP because HTTP is fine for low level. It just doesn't work on the high level SDKs. So we have a bunch of different methods. We have encrypt, decrypt, wrap, unwrap, sign, and verify, and also get key. In this specific case, I'm going to use my Azure keyboard, and I'm going to ask for the public key that corresponds to this gRSA key. Of course, you can never get the private key because the private key is stored safely inside the vault, but you can get the public key that you can use to perform operations such as encrypting data. Also going to use Azure keyboard to encrypt a message using RSA. So again, I have here the plain text, sending an HTTP request to Dapr, and Dapr responds with a ciphertext that was encrypted within Azure keyboard. So Dapr in this case never sees the private key because I'm using Azure keyboard. Likewise, I can copy paste that ciphertext in here and then decrypt it, and I will get the original message that I had at the beginning. Key wrapping and unwrapping is pretty much the same thing as encrypted, except that you work with keys. So the content you're encrypting is a key rather than any random arbitrary message. And in this case, I'm using the JWKS component. So I'm using a symmetric key. And you can see I'm going to use IS-256 in GCM mode. I need to pass the nonce, and this is my data encrypt, my key, sorry, wrapped. And same, I can unwrap the key. Lastly, I can also use the subtle APIs to calculate and verify digital signatures. And in this case, I'm going to use Azure Keyboard, and I'm actually using ECDSA with a P256 key. So I'm using elliptic curves here. I have a message, and then I included here the SHA-256 digest, sending a message, and you can see the signature. And then I can paste the signature here together with the digest in the verify method. And if the key is correct, I will get a valid, sorry, not the key. If the signature is correct, I will get a valid true response. This was very quick, I understand. This was just a quick overview of the methods that we have considered for the low-level APIs. And we would like to know if you want to use them, what for, and how can we best expose them. So the status of this is that the building block is in alpha in Dapr 1.11. And like I mentioned many times, we only have the high-level APIs that are public. We have 4 components at launch, 1 Vault, which is for Azure Key Vault, and then 3 components that use the built-in crypto engine. These are the ones where you don't have a Vault, or maybe even for local development. One uses local storage, so you just put a key in a folder in the file system, and Dapr can use that. One uses the JSON web key set, and one uses Kubernetes secrets to store the keys. 2 SDKs, Go has been merged, and JavaScript, TypeScript, it's being reviewed, should be done I think, I'm hoping next week at the latest. There will also be quick starts and docs that are going to come out. Like I mentioned, the low-level APIs are not available. If you want to try them, you have to recompile Dapr by using the Go build tag Sarol crypto. Very advanced thing, but it's for people who feel adventurous at this point. And this is what I wanted to talk about with regards to cryptography. Any question?
No, this is really cool, Alessandro. It's good to see this building block. It'd be great to see what people do with it and how they use it. So, and some of the scenarios you run into, and in the upcoming builds and in future releases. There was one question which was using crypto, like from Tiago, using crypto like this allows you for auditing who used which key when to crypt and decrypt depending on the crypto provider. Is that?
Yes. Yes, this, if you use a vault like Azure Key Vault, you can enable auditing. So you can see when the key was used, what was the credential that used the key, usually the application ID, and what operation was being used. The other similar vaults have similar auditing capabilities. So you can also pipe those things into us CM, SIEM, or whatever it's pronounced, and pipe that into your monitoring solutions.
Okay, are there other questions people want to ask about this?
Otherwise, I can go on to the next one, and then people can also ask me questions about crypto at the end as well. Okay, so the next thing is streaming. So this is something that we have been working on for quite some time, and it's something that is meant to improve the performance of service invocation in Dapr, especially the HTTP one. So quick recap before we talk about streaming is how service invocation works in Dapr. So just a quick refresher. So it actually involves 6 steps. So your app A wants to send a message to app B. So the first thing is that app A sends a message to the sidecar A. Then sidecar A sends a message to sidecar B. Sidecar B sends a message to app B. The response goes the other way around. So app B sends the response to sidecar B, which is sent to sidecar A, and then finally to app A. This is the normal flow of all service invocation in Dapr. So what's going on here? Okay, so let's look at the flow of data without streaming. So currently in Dapr, each step buffers the data in full. For example, if you want to transfer data that's 3 chunks, in this case, assume, for example, it's 3 bytes, using HTTP service invocation, this is what happens. First chunk gets sent to sidecar A, then sidecar A buffers all the chunks, sends to sidecar B, which buffers all the chunks, and then sends to app B, which buffers all the chunks. And every single step, the message is buffered in full before it finally arrives to app B. The response follows the other way around. So again, each sidecar buffers the message in full. So before it's sent to the other sidecar or to the app, the message has to be received in full by the sidecar. So what does this mean? Well, let's look at a demo. What does it mean to have service invocation without streaming? So I have it here. Okay, so I'm gonna show you a demo using Dapr 1.9, which is the last version before we did any work related to streaming. I'm gonna start a server that is the target of service invocation. And I'm gonna start a client, which is the client of service invocation. And you will see that the client is about to send a message. So it's sending the message to the sidecar, and it's writing the bytes. The file is about 70 kilobytes, so 70 something bytes. So the sidecar received it, and now it's sending it to the other app. And the other app is receiving it a little bit, like a few bytes at a time. Then it has it all, and then it's ready sending the response. So the sidecar, again, is sending a message, each chunk at a time to the sidecar, which is being sent to the sidecar of the client, and the client is receiving the data. And here, I hope, at least you can see what I mentioned about with buffering. where each step, everything is buffered within the Dapr sidecar. So when the client was sending a message, you saw that the server was not receiving anything until the message was sent in full. And the same thing for the response. The server was sending the response, and the client was not getting anything until the response was written in full and then transferred between the sidecars. Okay, so let's look at how we're improving this with the use of what we call streaming. So with streaming, we can make this much more efficient and fast. And the trick is to make the data flow from app A to sidecar A to sidecar B to app B as soon as the data is available. So here's how it works. Ready? 3, 2, 1. And you can see that the chunks of data flow from the app A to app B through the sidecars as soon as they're available. For the response, it would work the other way around. But I think there's enough PowerPoints, and also took forever to make this animation, so just picture it going the other way around. But I'm going to show you this animation again, just so you can see the actual data flow, and you can see that the chunks are being transmitted independently rather than having to wait for each step to buffer the message in full. So what does it look when we have streaming enabled? Here I'm going to show you same version as this. I'm going to keep this here so you can see also the total time, excuse me, the total time here it took to make this request. And I'm going to show you with the development sidecar that has streaming enabled. So starting the server and starting the client. Okay, as you can see, it's writing the data, and the other sidecar, the server in this case, it's receiving the data right away while it's still being written. And then the response same way, the sidecar is, the server is responding, and the client is receiving the data at the same time in real time. And total request duration, 14 seconds instead of 34 seconds. Even more importantly, the time to first byte is what saw the biggest reduction in response. The time to first byte means after the client sent the request, how long did it take to receive 1 byte in the response? And this was reduced from 24 to 7. And the time to first byte is very important, because as soon as your app starts receiving data, can begin processing it. And so this can make the perceived performance improvement quite significantly. By now, like, you might be thinking like, okay, like, Alessandro, this was an impressive demo, but you sent a 70 kilobyte file and it took 30 seconds. So you must have been making it artificially slower. And yes, I totally did make it artificially slower. But the purpose of making it slower was just to show the concepts and demonstrate like how things were buffered around, and the potential performance gains. So don't look at this in absolute numbers. Like 30 seconds is not what it takes for Dapr to send 70 kilobyte. What I wanted to show was the relative performance improvement when performing HTTP service invocation using Dapr. The perf improvements in terms of total request duration and or time to first byte are variable, but they will be bigger in certain cases, such as the ones that you see here. First example is when the amount of data in the request or response is larger. So, excuse me, the perf improvements are going to be pretty much minimal if the request is data or response data is less than 2 kilobytes. But the larger the data, the bigger the improvement you will see. Some real world use cases involve, for example, using Dapr service invocation to transfer a PDF to a separate service to run OCR. So to scan for text in the PDF, or maybe you want to transfer an image to another service to have a thumbnail generated. So all of these kind of things, they deal with larger files, and we'll see significant benefits from streaming. Benefits also happen when the producers, for example, in this case, the Keller app, so in my case was app A, are slow. For example, when the data comes from users, like, for example, it's something the users is uploading, or from a slow storage like S3 or magnetic disks that are slower, or when it's generated on the fly and it takes time to do that. For example, if you're querying multiple databases and putting or APIs and putting all the data together. All of these things that make the request take a long time to be produced in its entirety, we'll see benefits with streaming. You also see benefits more when the consumers, in this case, the target app like app B, slower processing the data. Some examples include things like processing OCR tools, like I mentioned, generating thumbnails, compressing videos, or even things like, I don't know, everyone is talking about machine learning models. So think about getting a response from a machine learning model. All of these things will get benefits from streaming. You will also get significant memory improvement. Although I wasn't able to show this in the demo because it was still too fast and hard to show the memory usage. That it's still 70 kilobytes, not a huge thing. Excuse me. When you buffer things, as you could have guessed, the data was kept in memory in every single step. Instead, when you use streaming, chunks are sent as soon as they come in, so Dapr needs much less memory to keep the data. One thing to note is that Dapr will still need to buffer things in memory if you use the resiliency, and your resiliency policy has a retries enabled, because in this case, we need to buffer the data to be able to retry the request if it fails. It will not hurt performance because even though we are buffering the data, we're also still sending to the other sidecar, but it does require more memory. In any case, you will still see that memory usage compared to Dapr 1.9 will be down. Lastly, there are also some side effects of this effort that we're doing. In order for us to have full streaming support, we are migrating Dapr's web server from this library called the Fast HTTP to the gold standard library. Among the consequences, which we welcome, are being able to support HTTP2 in the Dapr HTTP server, which means that codes from sidecars are going to be able to leverage multiplexing. And Dapr will also finally respect the context cancellation in HTTP requests, which means that when a request in flight is aborted, Dapr will stop whatever it's doing. For example, we stop reading from a database. So when can you have this? So some initial work was already shipped with Dapr 110 and is enabled by default. This is the stuff that you see here with a green check mark. So the communication between the target sidecar and the target app. Some work is implemented, but it requires a feature flag. It was added in Dapr 110. That's communication between the sidecars. And the full end-to-end experience of the remaining the red crosses are targeting an upcoming Dapr version. So the reason why 2 and 5 are behind a feature flag is because this is about communication between sidecars. And in Dapr, like without the feature flag, we use the traditional method, which requires sidecar A to buffer the entire data and then send it to sidecar B as a single invocation. Excuse me. Making this change to be able to send the data in chunks and use streaming is not fully backwards compatible. And so the target sidecar must support this method that we added. This feature, so this target method was added in Dapr 110. And if you want to test it today and enable streaming here, you can do that. The feature flag must be set on the caller side, so must be set on sidecar A, and it tells the sidecar to try and use the streaming communication channel. If the target sidecar runs Dapr 110 or higher, so even 111, even if it does not have the feature flag enabled, the connection works and it uses streaming. If the target sidecar uses Dapr 1.9, the caller sidecar will try to use streaming if the feature flag is enabled. If this is using Dapr 1.9, the connection will fail, and it will try again as long as it has a resiliency policy which with retries enabled. Yeah, the reason why the last step has been so complex, like steps 1 and 6, is for what I mentioned before about migrating the web server from Fast HTTP to the gold standard library, and it's something that hopefully will land fairly soon. And this was the full demo that I wanted to give about streaming for HTTP service invocation.
This is pretty good, Alessandro. We're a little short on time here at the moment, so I'm gonna have to sort of wrap up this little bit here. We got a few questions though, and that is, will this also impact middleware performance?
Middleware performance should not be impacted either way, neither positively nor negatively.
Okay. Okay.
I also see a question about gRPC. gRPC is an interesting case because this specifically is for HTTP. So gRPC service invocation should not be impacted significantly. I see someone mentioning that gRPC already supports streaming, and meaning that you can use gRPC proxying to stream requests. The thing you have to keep in mind is that in that case, you have to chunk the data to be able to leverage streaming. So even if you use gRPC proxying, but you send a 10 megabyte file in a single RPC call, that does not use streaming. If you want to stream the data so the caller starts processing as soon as it gets it, and you use gRPC proxying, you are responsible for chunking the data, so sending data chunk at a time. This is how gRPC works. And so, yes, it's totally possible, but this is specifically, this work that I presented is specifically for HTTP service invocation. And what I think I see Yaron commenting that, although not absolute, this could potentially make HTTP service invocation be more performant than gRPC, and at least some cases, the ones that I mentioned about earlier. I lost my pointer when I was showing who has the biggest perf improvement.
Yeah. All right, this is great stuff. I suggest that people can ask questions on the Discord channel after this, and maybe we can revisit this as a future topic and come back to it all, because we do have to move on to just our last section. So thank you for this and posting questions in the window. Marc, let's move on to you and wrap up with a little bit of show and tell about what's happening in the community.
Yes, let me start sharing my screen. All right, I hope you can see this. Okay, so yeah, there have been a lot of contributions, not so much in the Discord show and tell. So I definitely ask you, please, if you have something, created something, put it in there. But there's definitely a lot I found on the internet. So there are 2 more articles by Martino Bourdin about Dapr state management and input bindings and configuration. So he's continuing his Dapr series. It's great to see. I've written a Dapr workflow blog post. And then there is a meetup newsletter from the Sanjeev section that contains the Dapr updates. And then there are only 2 excellent blog posts by Abhishek Khosrowal about simplifying security in Kubernetes with Keycloak and Dapr. Also highly recommended. And I think we've invited Abhishek to also come over to the Dapr community call, I think for the next one, to present on this. Then there have been quite some events again. So here we see Mauricio presenting at Go to Aarhus about Dapr. He also did a session for Spring IO in the UK about test containers in Dapr. I did a presentation for TechNation in the Netherlands about Dapr Workflow. And I also did like a Dapr 101 session on a meetup also in the Netherlands. I'm working on some new Dapr stickers, so the left one are already here, and I'll be distributing them. So you can see them soon at conferences. And the next one I've actually created by request of Sam for GopherCon. Then there was I think it was a one-day conference or a meetup in Italy focused on .NET and Dapr as well. And here we have Adrian Cole talking about Dapr and Wasm and Kubernetes at GlueCon last week. And we have Jacob also talking about Dapr and Azure Container Apps at NDC Oslo last week. And last but not least, there was Microsoft Build, and there were a lot of Dapr related sessions. I think one of the bigger things was about Azure Container Apps. They can actually now host Azure Functions, and you can even now combine Dapr with Azure Functions on Azure Container Apps, which is really cool to see. All of the Dapr related links are in here, and of course we will share this also when we post the video, so you can definitely look up all these sessions again. And I think this one was the final update. It was very nice to see Mark Rusinovic talking about Dapr Workflow, and definitely in one of the closing keynote sessions with Scott Hanselman, where he was wearing his Dapr shirt. So that was a good promotion for Dapr. So if you have anything related to Dapr, you're building something, you're writing something, you're giving a talk, please post it on Discord in the show and tell channel, so to make my life easier, that I can highlight it in the next community call. Thanks.
That's a pretty cool. A lot of stuff been happening in the last week, especially with MS Build and all those sessions inside there, and great to see
a lot of news.
Yeah.
Exactly. Yeah, and we should definitely have some community call demos about these new features as well.
So yeah, and with that, we always want to ask for more community engagement and calls. So if there's things that you want to present or articles you want to post, just put them on the Discord channel, put them in the show and tell channel on Discord, or reach out to us, either myself or Mark or one of the other community managers, and we'll be more than happy to have you on one of these calls and kind of promote the work that you've been doing. So with that, I think we're going to finish up the call, unless there's any last minute questions anyone might have about today's topics. All right. Well, thank you for joining us this time, and we'll see you in 2 weeks' time for the next call. And I think, Mark, you're doing that one, aren't you? The next call, or maybe someone else. But either way, the next one in June, 2 weeks' time. See you on the 14th of June. Thank you.